All right. So yeah, homework, I mean, the word problems at this level are just basically plug straight in, so it's not a big deal. Let's go to about 45. All right. So inverse trig functions. Let's pull up a piece of paper again and talk about it a little bit. So we learned back in algebra to really have an inverse function, then, well, to be a function, you have to do the whole vertical line test, right? Inverse functions swap the x and the y, so you have to do the horizontal line test. We actually haven't graphed these things yet, but let me draw you right quick, which sine looks something like that. Does that look like that does a horizontal line test? No. So it doesn't really have an inverse function, or rather, if we want, it only has an inverse function like on a very small part. Yeah. Yeah. So for sine, they've decided that the magic region is from there to there, which this is negative pi to pi. If I go in there and I draw a horizontal line, then I only cross in one spot. So inverse sine, it always gives you something between minus pi and pi. Okay. Same thing, they do the same for tangent. So I just said minus pi to pi on both of those, didn't I? I just lied to you. Those pi's are all pi over 2's. Sorry. Pi would be out here where it hits 0 again on the edges. But the top and bottom are plus or minus pi over 2. And then cosine is from 0 to pi. So another way of saying this is sine. When you do inverse, you always get something either in Q1 or Q4. Same thing for tangent, you always get Q1 or Q4. Cosine, you always get Q1 or Q2. So, right? Otherwise, they're exactly what you think they would be. So if I go back to the problem, what this is saying, hey, what angle, either in Q1 or Q4, has tangent equal to root 3 over 3? Has everybody memorized their unit circle yet? Let's pull up the unit circle again. Apparently I can't spell. It's like Kayla says, what are the tangents? And Angel says, so is your face. Okay. So the x's are cosine, the y's are sine. To get the tangents, well, it's sine over cosine, so you're going to ignore the denominators, just look at numerator over numerator. So if I want root 3 over 3, also known as 1 over root 3, where would that be? That's why I prefer people to say 1 over root 3 instead of root 3 over 3. Okay, we're looking at the y over the x. So right here, 1 over root 3. Oh, whoops. I didn't mean to do that. The y over the x, 1 over root 3 would be what we're looking for. So pi over 6. right? Root 3 over 3 is the same thing as 1 over root 3. Okay. Everybody sort of happy? Pi over 6. You can have pi. That is the exact same question. Wow. No, because that one, that would be if you did inverse tangent of negative root 3 over 3. Because quadrant 4 slopes negative, so you should get a negative angle. Okay, apparently that's all we're doing. So we go back to our calculator, which these are Michaela's favorites. We're already in radians, which is good. We go 0.1. And inverse sine is 0.1. Nearest hundredth. Yep. And now I'm ready for Angel to say, oh, will that always work? It won't always work. But that's, again, that's kind of the reason people invented radians, because if an angle is very, very small in radians, sine of theta is very close to theta. And that was the reason for inventing radians. Okay, so 7 over 8. And inverse cosine, 0.50. And nearest hundredth would be 0.51. Michaela's very, very happy right now. I can see it in her eyes. Yeah. Ooh. Okay, so now we're going to think for a second. So sine 5 pi over 6, that means go to 5 pi over 6 on the circle, find the y coordinate, right? Inverse sine says look for that y coordinate in quadrant 1 or quadrant 4. So let's go back to the unit circle right quick. So 5 pi over 6 is where? It's over here in quadrant 2. Not there, right? The y coordinate is a half. So now we're going to look for the y coordinate of a half somewhere in quadrant 1 or quadrant 4, yeah, which is over here at pi over 6. So again, 5 pi over 6 over here, the y coordinate is right there, which is a half. We look for that half in quadrant 1 or quadrant 4, and it's here at pi over 6. Okay. Is that happy alone? Okay, just making sure. Yeah, if the y coordinate was negative, we'd have to look down in quadrant 4 to find it. But since we got the y coordinate was positive anyway, we're okay. Tangent of inverse tangent of 9. So we want the slope to be equal to 9. That doesn't really come out even. But slope equals 9 is like somewhere here, right? And now we want to find somewhere in, wait, let me go back. Okay, actually it is really easy right now. Because we're doing the inverse first. So we're saying the slope's equal to 9, which means we're right here. And then we're finding the tangent of that. And so we're saying, what's the slope in the place where the slope equals 9? Okay, I'm going to ask you another question, Michaela. What color is a white horse? What's the slope in the place where the slope equals 9? Yeah. So it's really easy if you actually just sit there and think about what it actually says. But, all right, Angel. Okay, this one's backwards though. So the other one, since we were doing the inverse tangent first, it was easy. This one we're doing the tangent first, so we're going to go the other way around. We're going to go to 5 pi over 4, find the slope, and then ask what angle either in quadrant 1 or quadrant 4 has that same slope, right? So go to 5 pi over 4, which is like over here. 5 pi over 4 is down here, right? So we want to find a place in quadrant 1 or quadrant 4 that has that same slope. What's the slope here? Yep, also known as 1. Okay, so where in quadrant 1 or quadrant 4 has slope of 1? Yeah, like weird Indian music or something. So slope equals 1 would be right here at pi over 4, right? Just turn the knob. You haven't had your coffee today, have you? Let's do a few more of these. They're good to practice our brain. Okay, so again, since we're doing the function first rather than the inverse, we actually do have to think about what we're doing. So we're going to go 3 pi over 2. Sine is the y, so we'll find the y coordinate. Then we'll look for something in quadrant 1 or quadrant 4 with that y coordinate. So 3 pi over 2 is down here. So what's the y coordinate? -1. And now something in quadrant 1 or quadrant 4 that has -1 for its y coordinate. It's down here again. Except it's not called 3 pi over 2 now. What's it called?
If it's a negative, then would it be pi over 2?
You almost said exactly the right thing. Pi over 2 is up here.
Right.
Yeah, it's at -pi over 2. I know. You're an angel. And a vampire. Ah. We're doing the inverse sign first, so normally that would say, okay, let's go to where the y coordinate is 5 pi over 3, and then what is the y coordinate what is the y coordinate in the spot where the y coordinate is 5 pi over 3? 5 pi over 3. Except, no, we're doing it that way because we're doing the inverse function first. So it says, where is the y coordinate 5 pi over 3? And then what is the y coordinate there? But it's a trick question. Why is it a trick question? Let's look at our picture. Where is the y coordinate equal to 5 pi over 3? Okay, how big is 5 pi over 3 roughly? Okay, like as a number. 5 times pi divided by 3. 5.23. So look at the picture. Where is the y coordinate in that picture equal to 5.23? Never. The biggest y coordinate you get is up here at 1, right? So, I mean, we would normally say, hey, what's the y coordinate where the y coordinate is equal to 5 point whatever? Well, it'd be at 5 point whatever, except there's not a spot where the y coordinate is 5 point whatever. It is undefined. All right, so these we can't use the circle to do anymore because, well, you have cosine and a sine, so it's, you can, but why would you? Come on.
Because April is feeling that we only have two there.
Okay, I mean this, so as far as what this says, okay, inverse sine of 5 over 13, that means go to the angle where y is 5 over 13. What's the x coordinate there? Because it asks for cosine, right? So we can't actually do it with a calculator. And we can do it with a calculator. I'm not going to. So I'm going to draw a circle. It was supposed to be 5 over 13, right? Yeah, 5 over 13. So I'm going to say that's right there. So here, the y coordinate is 5 over 13. All right? Which we know this is the unit circle, right? So the radius is 1. Y is that length right there, so that's 5 over 13. I'm looking for the x coordinate, which is that length right there. If I know 1, I know 5 over, how do I find the other side of a right triangle? Pythagorean theorem. So square root of 1 squared minus 5 over 13 squared, which is, this is 25 over 169. 1 squared is 1, which I'm going to write as 169 over 169. Subtract them. I get 144 over 169. And so the square root is 12 over 13. Don't you feel a sense of accomplishment since you haven't used the calculator to get the answer? All right, tangent of inverse cosine of 3/5.
You're so rude. He's always like that too. He's like, I did like 5 years.
All right. I'm just going to draw the triangle. I'm not going to draw the circle. So cosine is x, right? So 3/5. All right, what's the opposite? So, that's 4. And we're looking for tangent, right? Tangent is, okay. And we were looking for tangent of theta, right? This is our theta. So it's 4 over 3. Yeah, if you know all your perfect right triangles, you can do all these in your head. Yeah. I mean, this one is 5, 12, 13 triangle, right? The 12 is the opposite. I'm looking for opposite over adjacent, so it's going to be 12 over 5. Except it is going to be negative. Because that says it's in quadrant 4, tangent in quadrant 4 is negative. Oh, that one's not a perfect triangle. That's sad. Let's do it anyway. So 6/7. All right. So it says inverse tangent of negative 6/7, and then cosine of that. So I'm going to worry about the negative at the end. For now, I'm just going to worry about the 6/7 part. I did write that down right. Yes, I did. Okay. So tangent is in a triangle is which over which? Yeah, well, it's y over x, or opposite over adjacent, right? Okay. Or you can just say y over x. So I want that to be, whoops, I said one and wrote down the other. So I want that one to be my y and that one to be my x. So Pythagorean theorem, square roots, 49 plus 36. That's 70, 85. Is there a square that goes into 85? No, there is not. So that's as simple as we can get it. All right, and now we want cosine of that. Cosine would be adjacent over hypotenuse. And then the last thing is we need to figure out is it positive or negative? Well, inverse tangent of a negative is going to wind up in quadrant 4, right? Cosine in quadrant 4, is it positive or negative? It's positive, right? Because cosine's the x-coordinate. So in quadrant 4, the x-coordinate is still positive. So it is positive. Let's do one more of those and we'll call it a day. Oh, that one has an X in it. Is that scary?
No, let's just say it's
Yeah, it's easy. You can't, why can't you use what? Okay, so 9x, if I write it as a fraction, is 9x over 1, right? Yeah, they did cut cross country. It made me sad. I had a lot of good, well, I had a few good cross country kids. I didn't have a lot of good period, which is why they cut it. But okay, so cosine is adjacent over hypotenuse. So I want to put that as my adjacent. That is my hypotenuse. How am I going to find the other side? Pythagorean. So square root, bless you. 1 squared. So square root of 1 minus 81x squared. And that's all we can do with it, right? So tangent is, that's my, is opposite over adjacent. So it'll be 1 minus 81x squared over 9x. That's it. See, it wasn't hard at all. And that's something that's actually, that process right there, you do a lot of if you ever take a Calculus 2 class. So if you're going engineering, that's, whoops, I don't want capital X. Well, you need to be able to do that in Calculus 2. You do it a lot. So, cool.